to this session. It is session 4 of Unit 1 of Methods of Teaching Chemistry. This session is looking at two theories. They are situated cognition and information processing theories. Let's proceed to look at the objectives for this session. By the end of this session, you'll be able to explain the implications of the situated cognition learning theory and the information processing theory to the chemistry teacher. So now let's start with the situated cognition learning theory, the SCLT. Now this is a work of a Russian psychologist called Vygotsky. He also did a lot on learning among children. He believed that social interaction plays a major role in learning among children. Now, to this theory, individuals construct knowledge in a particular context through the interplay of previous experiences and the social environment in which the learner is situated. So there is an interaction, some kind of interplay, but it is between what the learner already know or the experiences that the learner has gone through and the environment. So here, social interaction is a major role in learning among students. Underpinning the situated cognition theory is the idea of learning as a socio-cultural phenomenon. By this we mean effective learning, and for that matter, learning of chemistry is the construction of knowledge in a context that reflects how it will be applied. Now, the theory requires chemistry teachers to support learners to build their knowledge base within a conceptual domain that draws upon their social background experiences and cultural worldviews. Remember, according to this theory, learning is an interplay between the learner's knowledge, the learner's previous knowledge, and his environment. And so the teacher, you should help the learner to build knowledge based on a conceptual domain that draws upon these two domains. Knowing this theory, what should the chemistry teacher do? In other words, implications of the situated cognition learning theory to the chemistry teacher. You should never teach chemistry in abstraction. Don't go to class and only talk about concepts that students can only imagine. They can only use their brains to imagine how the thing looks like or how it is going to look like. No. Go to class with something tangible, something that they can see, they can touch, and not even only taking it to class, sometimes taking the students out of the class also, because there are some of the things that you cannot take to the classroom. That doesn't mean that just go and talk about it and then let them imagine how it will be. Whilst the thing is just around, it's just a matter of taking the students out there to have a feel of it, or out of the context of the environment of the learner. Now, the issue is that chemistry is all around us. And you, the teacher, before you go and present the concept to your students, it is prudent to sit and then look through the environment. Find something that has a relation with the concept you are going to present to them. When you do this and students feel that what they are learning is relevant because it is in their context or because it is in their environment, then they would appreciate whatever you present to them and effective learning will take place. You should also bring reality to chemistry learning by locating the knowledge that is being transmitted in the immediate environment. For example, you are teaching saponification, which is about soap, preparation of soap, and you are in the environment or a locality where they produce local soaps, like the, in quotes, the Alata Samina. Please, this is a knowledge or this is something in the locality. Try to put this in the concept you are going to present to your learners. Don't go to the class and then describe how Lux or a certain soap somewhere is produced. They won't appreciate it. Let them see what is in their environment and they would appreciate chemistry. Now, a chemistry teacher should draw upon relevant examples. In this context, we are referring to examples in or within the learner's environment. Cite examples that they have come across, examples that they have seen, rather than citing examples somewhere. You are teaching sources of bases in a cocoa growing area where we know that ashes of cocoa husk can be a source. Then you are mentioning examples that they have not even heard before. That wouldn't cause effective learning. So you should take note of these implications. Now let's proceed to look at the other theory, which is the information processing theory, IPT. Now this theory was propounded by Gagne to describe the mental processes in learning. And the theory is premised on the assumption that learning processes are in two stages. What are these two stages? One is the receptive stage. What happens in the receptive stage is where the information is processed internally. So, what you present to them, they take it and then they process it. And the second stage is the retrieval stage, when information is stored or retained for subsequent use or action. And knowing this theory, what should you do? You should identify instructional events that can help students to effectively process information. In this, what are some of the things that you should do? You should be using stimuli to gain attention. Sometimes instructional materials are very effective in gaining students' attention. Use certain activities that will cause your students to react or will cause your students to provide certain responses. Also, use questioning or pretest to stimulate retrieval or recall of previous learning. Your learner is there, he might have the knowledge, but if you don't question him or her, he is not going to retrieve it. So you should be questioning your students. You should be pre-testing your student before an event or before a concept. You should test your students in order to recall some of the previous learning. And also you should provide feedback for reinforcement of learning. And this we mean timely feedback or immediate feedback. If students provide responses, try to let them know the stance of their responses. If you give projects, if you give assignments, if you give homework to your students, and they do and bring it to you, don't go and pack them somewhere and wait for weeks before you provide to them, by which time it wouldn't even be relevant to them again. Your feedback should be on time to reinforce learning, and also allow for repetition and practice through activities such as classwork, projects, etc. Now, when you do this, they will be able to retrieve what they have learned previously, and in this case too, they will be able to transfer the learn. For instance, you may give project work that they would have to transfer knowledge from somewhere, or even some of what you have taught them they would have to transfer to the project. Now, these are some of the implications of this theory, and this where we are going to end this session. We are ending with these questions. Please try them, and let's meet again in the next session.